Okay, greetings everybody. Welcome to the OPFs webinar on benchmarking digital preservation software tools arranged by the Technical University of Vienna. Just a few housekeeping rules at first. It's our first webinar using Google Hangouts, and there may be one or two small hitches. For that reason, and because there was a lot of attendees, we've given you rights to attend as viewers only rather than be able to use audio. If you want to ask questions, you can use the Q&A app. There should be a column on the side where you can type questions, and at the end of each presentation there'll be a chance for the presenter to ask questions, so feel free to type questions as you go. Thanks very much for attending, and without further ado I'll hand you over to Christoph Becker.
Hello, welcome. So yes, I'm the PI, the investigator of BenchmarkDP at the University of Toronto and Vienna University of Technology. And so the BenchmarkDP project more generally focuses on systematic assessment in digital preservation. And a key part of this is, of course, the systematic evaluation of tools. And so the webinar here is a bit of an extension of a workshop that we organized at IPRES to bring together the different types of stakeholders that are involved in this process. And Krešimir will talk a bit more about these roles later on. The workshop report is out in the current issue of the DLib magazine. And so one thing that was very visible actually at this season's IPRES is that after years of tool development, really many more organizations are now actually using them. And with that comes an increased awareness of the need to evaluate these tools more systematically perhaps than before. And so if plenty of organizations are now doing some sort of testing and evaluation, the question is, what if they pool their efforts more to conduct evaluation more collaboratively and comprehensively? And so in software, benchmarking is really a very specific term for a very particular method of testing that enables us to systematically compare multiple tools of the same kind according to a very specific set of criteria. And now that means that each benchmark has to be specified carefully, but then can help us to see how exactly tools perform according to the criteria we choose. And so that can be speed or performance, but very often other things are more interesting. Maybe what is the characterization tool that gives you the most detailed characteristics for PDF documents and more criteria like that. And so we're organizing this webinar together with the Open Preservation Foundation and with the PREFORMA Project. So we have in Vienna Krešimir Đuretec, Artur Kulmakometov, and Andy Rauber joining. And we have Carl Wilson at the OPF, and we should have Bengt Nice at the Swedish National Library and the PREFORMA Project, and so they will be speaking for the most part of this hour. Our reason for doing the webinar is not really teaching you how to benchmark. We'll cover this, but what we really like to see which types of tools you'd like to benchmark, if you want to join in on specifying some of those types and performance measures and comparison metrics, or play one of the other roles in this ecosystem that we can help the community in building. So in the end, software testing is quite expensive and difficult. There are different roles, and benchmarking is meant to provide robust evidence. And so this really helps to be a community effort. And so we want to provide a short baseline definition of benchmarks today, and take a few lessons from other fields. We'll keep this all short, just summarize some lessons, introduce a structure on how to specify benchmarks, and make sure we have time in the end for a discussion about these issues. And so I'll hand it over to Vienna for the next part.
Okay, good afternoon, warm welcome from my side. This is Andy Rauber speaking. Before we got involved in benchmarking for digital preservation, our lab has been working quite a lot on different benchmarking initiatives in other domains, specifically in machine learning and information retrieval. And what I'd like to do now is just to use about 8 to 10 minutes to introduce a little bit some of the activities that we have done there. Not so much to present you how benchmarking is done elsewhere, but talk a little bit about the lessons learned, the issues identified, and the challenges that we see in those benchmarks. We have done benchmarks in a range of domains, from text retrieval, classical machine learning, data analysis, classification tasks. up to more interactive settings, specifically in the music domain. And since the challenges that we are facing in digital preservation are a bit more ambiguous in the setting, require more interactivity, have a broader range of goals, I would actually like to pick an example from the music domain because I think it shows the most similarities to the domain that we are facing with. So what I'll do is I'll introduce briefly the Mirax Music Information Retrieval Evaluation Exchange, because I think we can learn quite a lot from some of the issues that were discovered over the years. Mirax is run since 2004. It's run as an open evaluation challenge. This is basically the homepage of the wiki, where people contribute tasks, share evaluations, and so on. And what I'd like to do is briefly go back to show how this benchmark was being established. The whole discussion started at a conference series, ISMIR, which is the Music Retrieval Conference series, in 2001, where people started discussing, pretty similar to the situation that we have now in digital preservation, is that there's lots of algorithms, lots of tools, lots of feature extractors from audio. How can we really figure out which one is working better, which one works better in which setting, for which type of audio should you use, which kind of tools, so on. Papers were being published, but people couldn't share the audio because of legal restrictions, so everybody was testing their algorithms on their own files. Again, this is a situation that might sound familiar in digital preservation, where we also find sometimes difficulty in sharing the data. We didn't have any standardized test collections to compare results on. The tasks were not really well defined. So people were, for example, classifying music into different genres, but everybody has a different concept of what a musical genre is. Some people stay at a very coarse genre of rock, pop, classic. Others subdivide classic and pop into 15 subgenres. So basically we had no clue or very little understanding of where the field and how well the field was progressing. So in 2001 we started discussing of how to establish a benchmarking initiative to help us really compare things and build on previous results. In 2002 the lab of Stephen Downey got a grant to actually start an evaluation campaign, a benchmarking campaign. And then in 2004 we ran the first, it was called an audio description contest. And you might notice the name change that we did from one year to the next, moving from a contest, which was set like a competition, really trying to get a ranking, who is best, to the Mirax, the Music Information Retrieval Exchange in 2005, where we obviously again evaluate the algorithm, but it's not so much about winning a contest. It's really about exchanging results and sharing knowledge about this. So the labeling, the naming itself already led to kind of change in the mindset. And to give you an idea, in 2004, we started off with 5 different tasks. One was genre classification, and we agreed on one type of genre that we wanted to, or one set of genres. It was 10 genres that were, for which data was provided, and then people had to extract features and train classifiers to automatically sort music into those genres. There was an artist identification task, melody extraction, tempo induction, and also rhythm classification. And what the people got was some training data, some test data, then they ran their algorithms, and then they submitted the algorithms, and they were tested then on unseen data, and results were published. Over the years, the tasks grew, and people were submitting new tasks. Tasks that were not considered interesting anymore were cancelled. And in 2012, we already arrived at a much, much larger set of tasks. I don't want to go through them in any detail, but just to show you, by 2015, so last year, we had an enormous amount of tasks that people were working on. And the way those tasks were being defined was basically, again, in a bottom-up approach, where on the wiki people were suggesting tasks where they wanted to test, evaluate, and compare their algorithms. And whenever there was a group of people, a sufficiently large audience, so to speak, interested in comparing their works in a specific task setting, then somebody would volunteer to run the task, set up the task description, collect the data, provide ground truth, and so on, provide evaluation criteria, and then people would be running the tasks. which means that new tasks could be established every year. Tasks that found no interest were cancelled. It was very dynamic, although over the years a few tasks really have been establishing them as long-term runners, so to speak. We basically have two different families of tasks. One is tasks that have an predefined and so-called objective ground truth that allows for fully automatic evaluation. Let's say, again, any of the classification tasks where you have to sort music into different categories, be it genre, mood, artists, instruments, whatever. You get training data that is annotated with labels, saying this is whatever category 1, 2, 3, 4, 5, up until category 500, whatever. People train their machine learning algorithms, train feature extractors, and so on, submit the model, and then a program is run in the background that runs unseen data through the model and computes an outcome. This is a purely objective evaluation. The debates that we usually get around those tasks is the goal that we are learning relevant? So is this really the correct classification setting? Is 15 classes correct, or shouldn't it be 17 classes? Should one class be split into 2? Should 3 classes be merged into 1? Again, the debate here is on 2 different levels. We need to agree on one kind of categorization that we want to learn, but once that is settled, it basically becomes a fully automatic machine learning task. And then there is all kind of statistical measures being computed on the robustness, tenfold cross-validation, threefold cross-validation, statistical significance tests. But this is fully automatic and an objective comparison. However, we have many settings, and I guess this is also something we will find in digital preservation, which are less easy to assign absolute ground truth to. And one of the examples that we have in music is a similarity retrieval task, where an algorithm gets a query song, a piece of music, and then the algorithm needs to select similar kinds of music and provide a ranked list of the 10 most similar sounding pieces of music. This is an example where it's very, very hard to assign a ground truth, especially if we have a music collection of whatever, 50,000, 100,000 songs, and we then would have to define for each query song the 10, 15, or 100 most relevant ground truth songs. This can't be done. I mean, people wouldn't be able to listen through hundreds and thousands of songs and match them up. So what we do here is that the algorithms retrieve the whatever 10, 20, 50 most similar songs. These are then pooled and evaluated by humans in listening tests. And what is being developed for that is the Evaluatron 6000, fancy name for an evaluation platform, where then 60 queries are randomly selected. There is around 20-25 evaluators, and each of the evaluators gets ranked lists to evaluate. And we make sure that each list is evaluated at least 3 times. And the evaluators don't get the results in the ranked order, but they see them as a blind list. They get the query song and then a few retrieved songs without knowing in which order they were retrieved. They don't know whether they were all retrieved by the same system or by different systems. They simply have to judge the similarity. And here's a screenshot of one version of Evaluatron 6000 from the 2006 evaluation, where they could listen to the query, listen to a candidate song shown in the top here, and then they can say, basically give an answer, is it not similar, somewhat similar, or very similar on a coarse scale, and if they feel confident, also provide a more fine granular score of between 1 to 10. This was also for us to evaluate and to understand how fine granular can people be in judging similarity. Are there trends? Are there people that always lean towards a range between 5 to 10, or are people very pessimistic and always give grades between 0 and 5? We also wanted to understand how this human judgment actually works across a broader range of reviewers, to detect how consistent are reviewers. If the same query song and retrieved song is judged by 3 different reviewers, how consistent are they? And it turns out that achieving full consistency is extremely hard. And you can try this yourself if you just listen to whatever, 5 different pieces of music and try to quantify how similar they are, and you do it 5 times on different days, you'll find how hard it is to get consistent judgment. Again, then there was a lot of metadata statistics and similarity and noise and bias evaluations extracted, and they are published on the wiki, and people can go through it, and that usually leads to very, very interesting discussions after the main evaluation period. The challenges that we found, and again here I want to draw some similarities to digital preservation, is along a number of dimensions. One is the data. What we want is real world data. How do we get that, and can we actually use it and share it legally? In the music domain, we can record data. There have been examples where people were actually paying an orchestra to play music, but this is not real-world music. It's not the pop music that's played on major radio stations. On the other hand, if it is really popular music, commercial music, you can't share it. So what people did is, and what we did in Mirax, is to keep the data in a central and closed-off repository. Only a subset of public data was made available from public sources for training the algorithms, and people would then submit the model to the data, and the data never leaves the secured server. So then the results are computed on a huge database of commercial music, but on a given site, not externally. The other discussion that is continuously ongoing is size. How big does a database need to be representative? And there has been no answer to that. Is it still valuable to run it on small tasks? Are results robust enough? And so on and so forth. The quality of the annotation also is a constant issue for debate. Annotations are noisy, and there are some people who argue that we should only use very, very clean data for training machine learning algorithms. Others say that in reality, if the data is noisy, and if an algorithm can't deal with noisy data, then it's not fit for real-world usage later on as well. So yes, noise is actually a desired feature. Errors in the data, errors in the ground truth are a desired feature. And there have been examples in IR for that as well. Same for metadata, what kind of labels do we need? Ground truth annotation, how much time should we invest? How much time can we afford to invest in annotating the ground truth? Evaluations, again, a topic that appears across all of these benchmarks. We all know that human evaluation would be qualitatively best, but it's also too expensive and it's not properly objective. Humans perform differently on each day. How do we evaluate it? How do we treat labels where humans perform inconsistently? So we have a high index inconsistency. And how do we compare that to performance on samples where the humans are very consistent in their judgment? So this shows that results, if they're aggregated on a numeric scale, they're good for producing a ranking and pronouncing somebody the winner and the runner-up. But the real exciting details, and the ones where we learn most of, is actually when we take a look at the detailed judgments, the detailed numbers, the graphs, seeing where we err on the wrong side, where we err on the right, where we take the right decisions. And where do the algorithms differ? Do they all perform the same on the same part of the data, or do some perform better where other algorithms perform worse? What we can, just to sum up briefly, is what we can observe is that the number of tasks is growing, which is brilliant because it broadens the type of topics that we are addressing. We see an increasing number of people who are interested in, and we see more and more labs participating, which on the downside also increases the workload on the people running the evaluation campaign. And Stephen Downey's team is putting more and more effort in keeping the whole thing up and running and managing the huge number of tasks and coordinating all the task coordinators. It becomes quite a major initiative. The data sets are growing in size continuously. We have more data available. It's more exciting to work on more data, but that also increases the computational load, storage, bandwidth, and everything. I think one important aspect is that Mirax is open to everybody interested in the evaluation. And this openness changes the mindset, and I think this is something important. It's not about separating the good algorithms from the worse ones, but to really see where the algorithms are working, why something is working better than something else, and see how we can then learn from that and improve overall. And suggesting new tasks is not a top-down thing, say we want a task here, but it's rather a bottom-up process. If somebody has a need, let's raise a task on that, let's raise a discussion and see whether there's other people who are interested in the task to launch it for the subsequent years. What we need for benchmarking this is very clearly identified. It's an infrastructure, somewhere where the data can be, where the ideas can be shared, where data task descriptions can be shared, where discussion on evaluation measures can be shared. It needs staff. It needs human resources to actually run any such benchmark initiative. And depending on the complexity of the task, this can be quite significant. We need participants who agree on a specific task. If everybody wants to run their own task, if it's too specific, then we can't compare anything. If we have 1 or 2 submissions only on any given task, it doesn't help us. But if there's like 5 to 10 groups who want to compare and share, then it's interesting. If the task is representative or not, is it relevant or not? Well, I would say usually if there's like 5 to 10 people, 5 to 10 groups who think that is of interest to them, that it is beneficial to run the task, even if it does not help to solve immediate real-world problems, but it gets us a few steps closer to real-world problems, then it is relevant to run. The more advanced a subtopic is, then the more challenging the task will automatically be. There have been benchmarks where participants basically reached almost 100% performance. Such tasks were then decided to be considered solved, and people moved on to more challenging settings and more challenging data sets. We need to agree on how to evaluate. Having a task, having the data is one thing. Having the participants is the second thing, but figuring out how to evaluate is always a challenge. And there's numerous evaluation measures. Which one is the true measure is not easy to come up with. Sometimes it makes sense to publish 5 or 6 different evaluation measures and agree that all of them measure something different and leave it then to the people. And the last thing is, this is a benchmarking initiative. It should not be a competition. Then people are just more interested. So what we need to sum up is towards collaboration and money to actually enable it. And this is just a quick run through from some of the lessons that I think that we can learn from, amongst many others, from initiatives such as Mirax and other ones. I'll now switch to chat window to see if there is any questions that people might have. Because I only see one window here, not 2 at the same time. If there is not any immediate questions, I can obviously take them later on as well. But if you have anything right away that you want to ask, just let me know. And if not, I'll hand over to Krešimir for the digital preservation benchmarkings.
Okay, I hope this is running quite smoothly now. So I will switch now to the topic of software benchmarking in digital preservation, because that's our goal, to establish this kind of initiative in our field. So as we know, in digital preservation we already have a lot of tools. For example, in Copter registry you can find already above 400 tools registered. And we know that there are different categories, and most obvious categories definitely are identification, validation, characterization, migration, emulation, but there are many more others. And what the community asks now, and especially in the last years via blog posts and different ways of discussing, is that we need high quality of those tools. We have a lot of tools, but the tools are not of sufficient quality, and therefore people are a little bit afraid of using them in real-world production environments. So that's why we are trying to establish exactly software benchmarking. Because if you define a software benchmark as a set of tests which enables us to rigorously compare software solutions for a specific task in digital preservation, then we can claim that this kind of initiative would help us to better judge the quality of the tools and better identify what are the important tasks that those tools need to solve and how good those tools need to be when solving those tasks. Andy was just briefly giving you an overview of benchmark initiatives in IR domain, especially in music information retrieval domain, and it's quite important to say that information retrieval domain is quite successful in applying benchmarking. And what can we learn from that field is basically they have 6 main components. They have tools and methods that need benchmarks. They have yearly meetings where they gather to discuss different benchmark results, different benchmark specifications. They have benchmark results which are driving each year the new creation of tasks, new development of new tools, and so on. The whole process is quite iterative. They have a community which is engaged in doing all the necessary work around the initiative, and they have specifications which are driving the whole benchmarking initiatives. So basically, if we would compare it for the digital preservation field, we can say that we have a lot of things in common. We already have tools and methods that we need to benchmark. We could have a yearly meeting. We started this year at IPRES organizing a benchmarking forum. We still don't have results. We are missing iterative process because this needs to run over a longer period of time. We have the community. There were some interesting talks on the benchmarking at our workshop. We had a nice number of visitors for our workshop. We have a nice number of visitors for this webinar. So we can say that the community around this topic is growing, and specifications, which we are lacking, but this is the place where we are making progress. So another thing what we can learn from the IR domain and from software engineering domain, where benchmarking is also established, is the benchmarking components. Basically, by fusing those two domains together, we have come up with a model of 5 most important components for digital preservation benchmarks. And those are basically motivating comparison, function, dataset, ground truth, and performance measures. So what is a motivating comparison for a benchmark? Basically, with motivating comparison, we are motivating the whole benchmark. So what are we supposed to compare in our benchmark? Which quality aspects are addressed with the benchmark? And what would be the whole benefit of the benchmark? Because if a benchmark is comparing something that doesn't produce any benefit to the community, then the whole benchmark is quite pointless, right? Motivating comparison, as I said, is mainly focused around software quality. As we know, software quality is actually quite complex, and it has different aspects that can be considered. And for that, we need to have a model, and ISO² is providing us a really nicely structured model which defines different aspects of software quality. And when we take a look on the things that are most important in the DP domain and what people are complaining the most is basically the correctness of tools. Basically, it's really hard to judge the tools and to say, okay, if those tools are actually performing the things that they need to perform in a correct way. The reliability of tools. There's a lot of complaint that some tools simply are not reliable enough because they hang on some input, they crash, and so on. And in the end, performance efficiency. We know that we have terabytes and petabytes of data to process, and of course, we need to have efficient tool to do that. Function, well, function for us, it's a rather simple thing. We need to specify a task the tool is expected to perform. The function itself needs to be representative of a problem in actual practice. We have a top-level hierarchy of our functions like identification, validation, characterization, migration, but we need to define those functions when we are defining the whole benchmark specification much more in details. Dataset, well, we can say definitely the datasets are the most important component of our whole benchmark. They will be most expensive to get, and in the end, they will have the biggest influence on the results. What is a dataset for us? Basically, it's a set of digital objects. Those can be images, audios, videos, and so on, but also they can be really a mixture of different kinds of objects that a tool is supposed to process. Certain aspects of a dataset that we need to consider because the quality of the datasets itself is crucial for the benchmark, and that's the topic that we are currently working on. But some high-level quality aspects that we need to consider for the dataset is definitely that the dataset needs to be relevant. It needs to be representative of the real-world problem. It has to be accurate. For example, if you have a ground truth together with the dataset and the ground truth says something that those values that ground truth provides, those values need to be accurate, and it needs to be complete in a way. Those things lead to some questions like how big do we need to have the dataset, and in the end, how do we generate it? Because we know that at the moment we don't have a lot of resources available for benchmarking in DP, and we need to find out what are the efficient way to generate those data sets. Ground truth goes together with the data set. It will be an optional element. Usually the ground truth we will need to have when we are interested in the correctness of our tools, and basically the correctness is quite important for the tools, so the ground truth is also quite an important element. The most important thing for the ground truth will be that it should be the machine readable, and it should provide correct answers to the for the tasks that tools are supposed to perform. The question, of course, will be which elements should go to the ground truth, and of course that will depend on the motivating comparison and the function that we have for the benchmark specification. And in the end, we have performance measures which will define the fitness of the benchmark tool. Basically some types of quantitative and qualitative measures, and in the end they can be human or machine made. So we had really nice discussion at IPRES workshop, and our conclusions after the workshop were basically that we have the community, we have a place where we could meet, which could be IPRES every year, we have tools, we don't have the iterative process, we don't have results, and we are lacking the benchmark specifications. Well, today, a couple of months after the workshop, we can say that things are changing, and we are starting to get specifications. We are working on different specifications, and we have identified some of the important scenarios on that workshop, and we are trying to phrase them in a really good way so the specifications are clear. We will present a couple of those specifications a little bit later. So now about you. So how can you help with all this? Well, for a starting, you can define a benchmark specification, full benchmark specification, but I know that this can be, for the beginning at least, quite a complex process and too hard. So the beginning, what you can focus is basically to providing only a motivating comparison. So we call this as a benchmark brief, where you basically only motivate the benchmark by providing some ideas on things you would like to benchmark in terms of the quality aspects. Would it be a correctness? Would it be speed, and so on? Which kind of task would you be interested in? Identification or something more specific? And maybe to give an example as some tools. You can publish your benchmark brief, of course, in different ways. At the moment, we are still lacking a central place to collect all the specifications, but as I see it at the moment, this benchmark brief would be a really nice blog post at OPF website. So please feel free to post any benchmark briefs as your blog posts there. And now I will give a little short introduction or short overview of one of the benchmark specifications that we are working on, and my colleague Arthur will talk about a different one. So basically, we are working on a property value extraction from page-based documents, and our goal is to address page-based documents. So as we know, we have a lot of different genres like books, articles, contracts, and so on, which are saved in different file formats, PDFs, docx, open document, and so on. So the idea is now that we have also a lot of tools addressing those genres and those documents and claiming to be able to extract certain properties. So what is a property for us? So property is basically a name certain attribute a certain file has. For example, file size could be a property of a file, and property value would be 12 kilobytes. What we are more interested is definitely in digital preservation domain is significant properties. Definitely file size is not a significant properties, but significant properties are something that are much more interesting for us. And certain tools are claiming to be able to extract also properties that we quite often consider significant. So as I'm saying already, we have different characterization tools. They are capable of extracting various properties. Now the question is, which properties can they extract? And those values that those tools are extracting, are those values correct or not? And exactly for that, we would like to propose a benchmark where we would motivate it as okay, we would like to compare the coverage and correctness of the tools when extracting different property values from documents. With coverage, basically we would see how good tools are in covering different properties. So if one tool is able only to select one property or all of them, which we find interesting. The question of which properties are interesting for us is a quite hard question, and actually we need to have some community involvement in defining those properties. Usually function should be based on some empirical work from before, and we have based this definition of interesting properties for us on plot of preservation planning experiments and case studies that we have done years ago. So when observing a couple of preservation plans which are interesting for documents, we have seen that the number of pages, text values, number of figures, and so on are quite frequently used as important properties addressed by those plans. So we could say that we should have some tools capable of extracting those properties. With performance measures, we are addressing coverage and correctness, which would say how good the tool covers the properties and how good is it when extracts the values of properties. And critical points of this benchmark is basically the function itself, which properties are important and how do we find those. Dataset, which I haven't been talking a lot because dataset is still a thing that we have to create. So what should be what should the dataset cover? We are interested in Microsoft Word 2007, but still Microsoft Word 2007 we can have a lot of different documents in there. And how do we create such a dataset? And in the end, performance measures, which measures are capable of showing us the exact coverage and correctness of tools, and how do we calculate them, of course. The next benchmark that we are interested is photo migration benchmark, and this will be briefly presented by my colleague Arthur.
Okay, thank you. My name is Arthur, and I will quickly introduce this photo migration benchmark. So basically, we are speaking about raw photographs. Those are the images produced by digital cameras, and basically most of the camera producers, they have their own formats to store the images, the content of that, of the pictures, and since there is a big variety of those formats, and no one can guarantee that one particular format will last longer than others, there is a risk of obsolescence, and this is very critical for digital preservation because no one wants to lose their content because of some producer drops support for their formats or tools. And the common recommendation is the migration to a standardized format. In this case, that is Adobe Digital Negative. That is standardized and highly recommended for this purpose. So, as well, there are also many tools that could be used for photo migration, and they support migration of raw images. And for example, those three, the Photoshop, Digicam, and the Capture One, they support migration to DNG. But here is the question, which tool does the migration correctly? Can we actually trust them, and what would be the evidence? And the most importantly for us, how do we select the best tool for migration to DNG format? So that would be our motivation actually. So we want to migrate images from raw to DNG, and we want to compare the correctness of those tools and probably answer those questions. Okay, and yeah, so our benchmark, the dataset for our benchmark is basically a collection of photographs that are stored in raw file formats, and they are created by sampling real-world collections. Particularly, we agreed that during our during our workshop, we agreed to use 3 sources of photos for our dataset. The one is coming from raw sample CH, that is the website that collects the samples of photos produced by different cameras. The second source is the photos that we got from the Get Research Institute, and the third one is the samples from comparison tool from dpreview.com. And speaking about performance measures, we identified 3 of them. First one is the metadata migration score, which basically compares the metadata before and after migration and calculates the correctness of this process. The second thing is content migration score, and it calculates the difference in content using a structure similarity index, and it is able to show how similar the result of migration to the original image. And the third measure is the amount of failures. It shows how many times do we have any errors during migration and do not get any results from it. Well, that's pretty much it.
Okay, so we have briefly introduced what our goals with benchmarking are in digital preservation, and we have given a short summary of 2 scenarios on which we are working on. And now I would briefly just check with Carl if Bengt has managed to join, or should I present our collaboration with PREFORMA. So I suppose Bengt is not here. Okay, so Bengt is not coming, so I will just briefly talk about our collaboration with PREFORMA. So basically, PREFORMA is an EU project which has a goal to address a couple of file formats which are quite common in different memory institutions like National Archives. Those are text-based, audio-based, and audio-based and images. So what is their idea is they are subcontracting different projects. One of the projects is definitely a Vera PDF project, which have a goal to build a conformance checker of certain file formats. So, for example, for text, where they are interested especially in the PDF-A file format, Vera PDF project is building a performance validator, which will be able to validate if the file coming to an institution is conformant to PDF A file format. So for them, definitely it sounds that benchmarking is an important aspect, because they need to evaluate those tools that they are building in terms of their versions. So they would definitely like to show that version 0.7 is better than version 0.6, but also they need to evaluate tools in comparison to other validators available on the market. So in that case, they see benchmarking as a really important aspect, and that's why we have established a little bit closer collaboration between BenchmarkDP project and the PREFORMA project. So our goal is basically to come up with 3 benchmark specifications, one addressing PDF-A validation, the other 2 will address the images, which are TIFF file formats, and the third one will address video file formats. Currently, we are working on these specifications. We have been mainly focusing, especially in the IPRES workshop, on the PDF-A validation benchmark specification, and hopefully soon we will have good results in that direction. So basically, I hope that they have managed to cover the PREFORMA project in proper words. And too bad Bengt couldn't join, but he has some firewall problems. Otherwise, I think from our side we are done, so I think we could also switch now to Carl, and he can talk a little bit about format identification, which is also an interesting benchmark, and especially give an overview of the technical infrastructure he's setting up at the OPF to support the whole benchmark process. Carl?
Hi, yeah, thanks Krasimir. I'll move on to sharing my screen. Hi, so my name's Carl Wilson. I'm the technical lead at the Open Preservation Foundation, and I'm just going to give a short introduction to the work I've been doing on putting together a test framework for comparing format identification tools as part of the benchmarking project. That's just a little bit about the OPF, only to let you know really that we do now have our new executive director in place. For anyone who didn't know, Joachim Young started at the beginning of December, replacing Ed Fay, who left at the beginning of September. Some of you may well know him already, but we're still just publicising his appointment, as not everyone's aware of it. Okay, I'd like to say a little bit about the OPF's role in the benchmarking project. So the OPF are committed to improving the quality of open source tools in general. We're really committed to providing good open source tools for people's digital preservation workflows. This is separate from the benchmarking project, and we believe that this is best addressed through testing, and particularly automated testing of software tools against predefined corpora. So there's an obviously nice fit with the benchmarking approach, and we also, so our particular role in the BenchmarkDP project would be to provide expertise around the development and automation of software testing. So one of the things I've concentrated very hard on in the last 3 years while I've been with the OPF is automated build and testing of our own software tools. And I'm quite used to basically continuous integration builds, publicizing results, and we've got a fairly stringent system set up for the Vera PDF project, which is part of PREFORMA, which is also another arm of the BenchmarkDP project. Just the disclosure there is we're being a little careful about our role. We don't want to become involved in the PREFORMA side, because that will be eventually testing the product we produce. So we'll be a user from our involvement in Vera PDF and PREFORMA, but we were also hoping to provide an exemplar of automated testing and producing data for the BenchmarkDP project. So the first question was what to benchmark. Well, the OPF and myself have had ambitions to test format identification tools, and this has been for a couple of years. The main reasons for that is there are a variety of tools available for format identification. These tools give differing results, and that includes tools that use the same signature data. When I say signature data, is a lot of format identification tools basically use recognized or predetermined patterns of bytes that are unique to a particular format to identify tools that format. That might be called signature data in the case of Pronom, or magic data in this case of the file utility. But even tools using the same signature data, particularly on Pronom, don't always give the same results. And also that format identification is kind of a vital first contact step in most digital preservation workflows. So knowing what format or what file you have accurately as soon as possible. Okay, so my initial aim has been to start as simply as possible. I liked the idea of using format identification data because the data itself is fairly straightforward and the outputs are well defined, meaning that they really only do one thing and return a single identifier. That identifier isn't always the same. Some tools use MIME types, where there's 3 tools that use the pronom signature and then return pronom unique IDs, or PUIDs. So to keep it as simple as possible at first, I've started by evaluating the 3 tools based on the pronom signature data. This gives us a straightforward data set, i.e. the identifiers are the same, there's no mapping between MIME types and pronom IDs. And there's less to compare at first as I build the framework. So the idea is the framework will be a bit more general purpose and allow people to compare sets of results and highlight the answers, highlight the differences. But starting with a simple data set, or relatively simple data set, seemed the best way to go at first. even then, there's even starting with these just 3 tools and the same signature files, there's still many different versions of the tools and 84 different versions of the pronom signature data, although some are very old, to be going on. So it gives us plenty of combinations to test. Okay, so the initial aims are we can use benchmarking to measure many different properties of software, things like performance, even usability, although some of these become more subjective. But we'd like to start by examining just 2 aspects of format identification: accuracy, which is just that's how accurate the tool is in identifying files of different formats, and coverage, which is a slightly different concept but related. That's how many formats the tool's capable of identifying from the set of available formats. Say a little bit more here. So in order to do this, we need some kind of ground truth, and that's yet to be firmly established. Ground truth referring to the accuracy of the data sets we're using for testing. So this is one of the first areas where people might be able to get involved themselves as well. So for accuracy, we require test files where the format is known to be already pre-known or is established by a tool known to be correct. And one way of knowing the format of a file is to actually use the correct application to produce the files. For instance, if you use a particular version of Word, you know reasonably, and you've selected the right file type to save, you know fairly well what the format of that file should be. So the problem from a point of view of testing is finding a set of files that the format's already known. I'll cover the corpus we're using in a little bit, but initially I'm going to take a fairly naive approach, or I am taking a naive approach, where I just compare the results of the tools. Where the tools agree, I assume the answer is accurate, and I'm investigating the cause of differing results at the moment. And this is just adopted to make life easy at first, and hopefully establish some level of ground truth. But what place I would like people who are interested in getting involved is offering corpuses of files where the formats are well known or have been determined, preferably manually, but by a different tool at least, rather than the 3 pronom-based tools that I'm using. So I'll cover them in a second. The other one is coverage. So ideally here we'd have a master list of all possible formats or all existing formats in the world, but this doesn't exist. Places to start at the first are using the signature files as different tools gives you a list of different MIME types, which gives you some idea. But at the moment we only have the one signature file, which is pronom, because all 3 tools are pronom based. As I say, that choice is deliberate to keep things simple. But so we know for a fact that in theory the coverage of the 3 tools should be identical. But there are some available resources. IANA do a list of known MIME types. The UK Web Archive also produce a list of formats that they've harvested. And then also by examining corpora themselves to see the variety of formats they hold. Okay. So my initial scope has been to compare just the 3 format identification tools that are based on the pronom signature files. So these are Droid, which is the original pronom-based tool created by the UK's National Archive and developed in Java. Fido, which is an OPF tool developed in Python that again uses the pronom signature files, but actually goes about identification in a subtly different way. Droid has its own pattern matching, expression matching algorithm. Fido actually converts the Droid signatures into something called regular expressions and uses them to test the file. And then finally Siegfried, which has been recently developed in Go by Richard Lehane from New Zealand. Again, this is based on the pronom file, but this uses its own tool to compile the signatures into a slightly more efficient form for Siegfried. So although all 3 tools use the same signature files and should in theory deliver identical results, in the real world they actually don't, because they've all done, or Siegfried and FIDO have actually performed some processing on the signature files, changed the forms of the signatures, and used subtly different algorithms to perform the identification. It's not theoretical. The tools do disagree on individual files, so they don't always return the same ID. Initially, we're using two sets of corpora for data, something called the GovDocs selected corpora. So the link for the GovDocs corpus is on there. This is 1 million files that were harvested from the web, but it's a little short of 1 million since they had to trim one or two, a few thousand out. But 1 million files of different format that were harvested from the web and made publicly available. Unfortunately, that sets 1 million files is very large to be developing software against. It takes a long time to run through the files. So we're using a reduced set, which has had duplicate examples of the same format removed. There's not just one file from each format, though. The files of the same format that have different producing software, it's known that different software has been used to create it, have been kept. So, for instance, there are about 4,000 different PDF examples in there, but it does trim the 1 million files down to a more manageable 25,000. And then the OPF format corpus, which files that have been put together by OPF members to represent different formats. Part of the reason for using these two corpuses was that they're both open source, effectively open licensed, and people are free to use them. So I'm really interested in people's suggestion for other test corpuses for format identification. So ideally, these would be corpuses that A, represent many different formats, but B, more importantly, ideally the formats would be predetermined. This could be by another tool that isn't one of the three tools, the three tools under test, or by someone's hard work. As if, for instance, as an example of that, we are hand producing files for the Vera PDF, test files for the Vera PDF project, and I think the corpus, although it's hand produced, is now running at about 1,000 files. So these things it is possible to produce synthetic corpuses like this, but real world corpuses are generally better. The initial design of the tool is fairly simple. The idea is that I'm not actually running the tools themselves through the framework doesn't run the tools themselves. It just processes the data that's produced by those tools. At the moment, I'm taking a very simple approach of running the tools and just piping the results to a file and then processing those files. Once the software has a concept of different corpuses, so it keeps track of different corpuses and the individual files in there, which are uniquely identified by their SHA-1 hash rather than the file name. So we only have one instance of a particular file. Obviously, the names, extensions, etc., can be changed in locations, but the SHA-1 gives a permanent identifier to the particular file. And once they're imported, it processes the data and makes it available over a set of RESTful web service endpoints. And the data is available as XML JSON plus the CSV raw results. As that, it just happens that the three tools I'm testing at the moment all produce CSV as the raw data. But yes, I haven't quite decided with the REST service at the moment. It says CSV, but that might become just the raw binary version. And on top of that, each endpoint provides an HTML representation as well, which is just converted from the XML. And the idea is that once we've established accuracy and coverage between the three, coverage less so, but the accuracy between the three pronoun-based tools, we'll expand this approach to cover the other two main format identification tools, which are the UNIX file utility. This comes bundled with most UNIX systems and is in many ways the granddaddy of format identification tools. Most web servers, etc., use this tool to determine the content type of the file they're about to send out. And Apache Ticker, which is really a characterization and content extraction tool, but it also supports format identification and has an easily parsable and understandable signature file that contains a different set of signatures to the other tools. Okay, At one stage, I was hoping to give a demonstration of the tool at the moment, but it's still under development. So a demonstration right now it's changing quite a lot. But the first endpoint, public endpoint, will be made available in the first week of March, and I will be publicising that first to members or people who have attended the webinar. And then there'll be more public announcements as well. But yeah, I'm still probably a couple of weeks away from being able to put the thing live at the moment, and it's not reliable enough to demonstrate at the moment because it's still under development. And yeah, I've been busy on it over the last couple of days. Okay then, that covers everything from myself. I'll hand over to Kresimir again now.
Okay, so I think we have used all of our time. I still hope that we have a couple of more minutes for question and answers. I don't see any questions relating to the presentation, but if you're not aware, there should be a question and answer button, and you can easily pose a question, and then we will see it and we can answer it. Otherwise, if there are no questions,
it would appear not.
Yeah, I hope that everything works.
Yeah, I mean, I'm sure that people can ask questions because people asked a few questions at the start about the availability of the audio and video. So yeah, I think the mechanism works fine. We're presuming that there are no questions then. I think all that remains to say is thanks very much for attending. The slides and video of the webinar will be made available.
Yeah. No. What also I would like to ask, I mean, if anybody has some suggestions for benchmarks, benchmark specifications, you can also post them here. We can briefly discuss them just, or as I said before, try posting it as a short blog post or somewhere on your site and point it to us. We are hoping to establish a central place where we would be able to discuss these benchmarks more centrally and have all the materials in one place. That definitely be beneficial. And also a question is exactly, do we see a need for this kind of work? I mean, IR obviously has a huge need for that, but do we have the same need? We are thinking that we have, but maybe you have a different opinion on that. So, but otherwise, if no comments, no questions, then I think we can also wrap up. So I think Carl will, as a lead of the webinar, wrap up the whole discussion and goodbye.
Certainly, just to say thanks to very much to everyone who attended, and the recording of the webinar and the slides will be made available early next week. Once we've just had time to just go over them and put them on place, but we'll let everyone know. All attendees will get an email with the links to the slides and the recording. And have a nice rest of your day. Thanks very much for attending. Goodbye.
Bye-bye.
Bye.